Good morning, everyone. Well, I guess it's not morning for everyone, depending on when you're watching this, but it's morning for me. And officially, winter has arrived. I know I've talked about it a little bit, but it is currently minus 29 out there and feels like minus 43 Celsius. Poor Duramax has been relegated outside just because I need extra space in the shop to work. So we've got the Jeep in the shop right now. We're going to go load it up with our transmission cases, go get those all cleaned up, and then we'll go from there. Alright, going ahead and go wash this transmission case. Got it all loaded up in the Jeep. Of course, for whatever reason, come out only when it's minus. I thought I heard a little bit there. But you know, only when it's minus 40, the blower motor on the Jeep quits working. So I guess we're going to have to fix that here pretty quick. So I know what you're thinking, like, I wonder how that thing does in the snow. And I can tell you, it actually is great in the snow. However, on ice, it is the sketchiest thing you could possibly drive. So, gotta be careful of that. And we are back. So, got the case all washed up. Probably go through and just let it all dry. One thing that I didn't mention is that I am going to build both of these transmissions simultaneously just because I have the other core apart. And I'm not entirely certain what transfer case I'm going to go with yet. So, I'm going to build this one, which is a 4-wheel drive. And then that one, which is a 2-wheel drive. With the long spline output shaft that we've got here. So depending on what transfer case I choose and what adapters I choose, I can either cut down that output shaft on the 2-wheel drive, or I can use this 4-wheel drive one. Something I've been kind of playing with, I haven't really mentioned too much on, is I do have a 3D printer, and I have printed a few things, well, quite a few things to be honest, over the last couple of years. I'm looking to kind of get into it a little bit more. So just for instance, I figured I'd give you kind of something that I'm going to do here, a little project. I'll show you. So this is the electrical plug that goes through the case, and as you can see, it's got 4 little, let's see if we can focus here. Yeah, so there we go. We got 4 little taps, and those have to all be pushed in at the same time. So yeah, I've seen people use sockets for it before, but I am going to design up a little basically a little ring that I can print, and it will just slide right on there, push all 4 of those in, and then push this right out of the case, no problem. So I will show you kind of basically the dimensions that I'm going to come up with, and then I will maybe show a little bit of printing it as well. Okay, so this is going to be fairly hard to measure at the same time, so I have already measured it. Basically around this way I got 36 millimeters, so that's going to be enough to, that's going to be the inside diameter, so that's going to be enough to like compact the little prongs right here. And then it will slide in, and then I'm going to do it about 30 millimeters deep, or actually, wait, did I come up with? Sorry, I think it was 40 millimeters deep. And then the only thing you have to keep in mind is when you've got this little bracket on here, like this one does, it can't be any thicker than about 6 millimeters right in between here. So those are the dimensions I'm going to come up with. We'll go into Fusion 360 and we will design the piece, and then we will print it. Okay, here we are in Fusion 360. I've already gone through and set it up, but I kind of wanted to show you just, how it works. So basically we started by just doing a sketch. We wanted our inside diameter to be 36 millimeters. That was what we measured on the connector. And then we basically wanted a wall thickness of less than 6 millimeters. That way it'll fit in between that bracket and the connector. So because I have a 0.6 millimeter nozzle in there, I like to make sure that my thicknesses are a factor of 0.6. So 4 passes of 0.6 gives you 2.4 millimeters wall thickness. So we increase we have our other circle's diameter be 4.8 millimeters larger than 36. So then we're going to get 4 passes of the nozzle to go around, so that's going to give us a nice strong support. And then once we have the sketch done, we extrude it, and then we get this cylinder. So that's already done. I did end up going 30 millimeters deep. I did some measuring obviously with not holding the camera on the calipers, and that should be plenty of depth for our electrical connector. Then what we're going to do is we're going to go over to manufacture. And I've done quite a bit of tuning on this printer already, so I know what to expect. I have different print profiles already set up. But one thing that I always do is I make sure that I go down into here, generate the toolpath, and then I do a simulate additive toolpath. And then what that's going to do is just show the actual movement of the printer. So You know, if I've messed up one of my calculations or something, I should be able to figure it out here. But it looks like we are doing 4 paths on the wall. So I think we're all good to go there. Next I will show you how it looks on the printer, maybe do a time lapse of it actually printing. Alright, so there's our finished product. Second thought, well, I mean after I printed it, I realized that I should have put a little bit of a bevel on it just so it's easier to get on there, but nothing a little wire wheel couldn't fix. So now, basically, what you do is you just slide it on over top of this, of there, and then what I usually do is I'll grab a screwdriver and just kind of pry from in there, but I already did it, so again, hard to do with the camera, but it brought all those off, and then this will slide right out. Guess it helps if I'm actually looking at the thing. And there we go. So if you look at it, here's another harness I got here. Basically what it's doing is it's just compacting all these tabs. So you put it on there, what side did I do? This side, you put it on there like this, and boom, they're all compacted. So, figured I'd show doing that. Just a cool little Sunday project. Now, I know everyone is expecting to, you know, finish off the assembling the rest of the transmission, and I'm gonna go through the modifications I'm gonna make to it, but unfortunately, right now, we're at a bit of a standstill because I thought that I had a Torrington bearing that I do not have. So we're gonna put it right down there in the bottom of the case, literally the first thing that has to go in there, and it's not gonna be here till tomorrow. So instead we are going to pull down, well, bring the truck down and then grab the block out of the back of it and get it set up on the engine stand, and then take a look at you know, cam bearings and kind of go from there. Actually, it looks like I already crowned the cam bearings out, so I'm going to have to install cam bearings in it first, so I'm going to do that before I put it on the stand. Alright, and back by popular demand, we have Amy.
Hi, Christy.
So we're here to make a big, bit of a big announcement. So we finally got a deadline for the Blazer, or well, probably needs to be done a little ways before this just to make sure the testing goes good. But Amy is all entered in Miles of Mayhem 2024.
Stoked.
So she's going to be racing in the 7.5 class. So we got to make sure the Blazer can go 7.5. Don't think that should be a big issue. And we're going to try and travel around with all the guys. Miles of Mayhem was a great experience. Amy's never actually been on it. I've done it one time, so pretty excited to do that. And then I'm going to try and film it all for the YouTube. So guys, stay tuned for that.
Yeah, and I am accepting call-outs, so if you want to race me in the Blazer.
Practice call-outs. There you go. Everyone's putting everyone on notice.